Good evening, all. I hope you're all doing well. We'll start for the day. Shashank sir, you can take over the class.
Sure, ma'am. I'll just share you the data set link also, ma'am. In the meanwhile, anyway, for a few minutes, I have to explain the concept, and then in the meanwhile, people they can download the data set.
Yeah, sure, sir.
Yeah, I'll just share you the link. So we'll start the session. Let me share my screen. The data set is actually a big one. In the meanwhile, you can download, keep it for download. Anyway, we have to discuss the concept on decision tree first, and then let us talk about the data part. Okay. Let me just open the data set also. Let me share the PPT. Okay, now I shared the drive link. Okay, fine. Let me share the screen. Okay, so let us start the session. Yeah, good evening to everyone. Good evening, all. Let us start the today's session. So today let us discuss about the concept of decision tree. Okay, so let us understand what is a decision tree first. Okay, and after that let us go into the practical part. Okay, and let us try and understand. Okay, so the data set I've shared. In the meanwhile, you can keep it for download. So it's a huge data set actually. That is an online fraud detection data set. So in the meanwhile, you can keep it for download. So first, let us understand what is a decision tree, okay, and why a decision tree is actually used, right? What is the importance of decision tree, okay? So when I talk about decision tree, there is also one more. Okay, I'll make sure Purva that it is sent. Yeah. So when we talk about the concept of decision tree, the most important thing is there is a sibling for decision tree who is random forest. So we also need to talk about random forest. Okay, so since together we cannot talk about decision tree and random forest. So for the first, let us understand what is a decision tree, and then let us take forward how to link decision tree and random forest, and how a random forest is very important, and it's a very important machine learning algorithm, right? So, and to understand random forest, it is very important to understand decision tree. So we cannot just skip a decision tree and directly go to random forest. Okay, so that we cannot do. So that is the reason a decision tree has to be discussed as well. Okay. Now let us start. What is exactly decision tree, right? So in the name itself, there is two parts. One is decision and one is tree, right? So now here, if you see carefully, we are saying that we are taking a decision based upon a tree, right? So what exactly is tree? So tree is nothing but a branching structure. For example, let me just show you a very small picture, right? So we'll go a little deeper when we go a little further. But you can see that here tree indicates, a kind of tree, really a tree, right? So what exactly a tree actually has, right? So tree has roots, branches, and internal leaves and all those things, right? So why we are using a tree structure is to build branches, okay, of decision. For example, if you take a particular decision, what are the outcomes? So if you take a decision one, what are the outcomes? Decision two, what are the outcomes? Decision three, what are the outcomes? Again, for the outcomes, again, if it again has a if condition, again there is a decision, again what are the outcomes? So like this, it goes on, goes on, goes on like a tree structure, right? So that is why we are calling it as a tree, right? So basically, tree is nothing but a graph, right? So something which is a network which is closed is basically called as a graph. Something which cannot be closed, I can say, unclosed graph, or something which cannot be closed. So that becomes a tree in computer science. So this decision, basically we are taking on some particular parameters. That particular parameters, right? How to start building a tree and how to take a decision based upon certain parameters or certain features in the data set, right? So all these things are actually put together in the form of a tree structure to understand how we can actually take a decision, right? And how things actually work, whether it might be a classification or a regression problem. So there are two different kinds of approaches in decision tree. So decision tree and random forest are one of the few algorithms which can actually do both, right? Classification and regression. So here we will focus more on the classification problem also, as well as the regression scenarios. We'll understand both how it can be actually used. So as we already have discussed, what are these? Let me skip to the next part. Okay, so this is how a decision tree actually looks. Now, before going into the terminology of what is a decision tree, let us first understand a basic structure. Okay, I've shown you how a tree actually looks, but let us see how a decision tree actually looks in a machine learning algorithm. So basically, you have something called as a root node. From a root node, we will have a splitting part, right? So that becomes a decision node. Okay, so that we are also calling as branches, or we are calling as a subtrees. So for a particular decision node, again you have a terminal node or a decision node. If you are having a decision node, again that decision node will have a particular outcomes, right? So that outcomes might be terminal or might not be terminal. So terminal means there ends the decision. There is nothing more to go ahead and break down the decision node. Okay, so something you cannot even you cannot go further and break it down is basically called as a terminal node. So here where our tree structure based upon certain parameters, right? For example, there are many parameters like the entropy, green index, and all, right? We will understand one by one each concept after the other. So build upon, or based upon certain aspects, right? How we have a decision nodes or a terminal nodes is what the decision tree actually tells you, right? So let us go back a little to understand that what are the types of decision trees. So we have, most important ones are the ID3 and C4.5. We also have C5.0 as well. And we have basically this ID3, C4.5 and C5.0 basically are used for classification tasks. Okay, so they're basically used for classification tasks. So ID3 as well, C4.5 and C5.0. So these are basically used for classification. And the measure, which is, I can say the measure on which, right? The tree starts to, splitting, right? The tree starts to split is based upon the concept of entropy. Okay, so what is entropy and all? I will, give you index and how this impurity and all those things that, I'll just explain in the coming minutes. So you know this ID3, this classification part in decision tree, which is ID3, C4.5, C5.0, all these things are basically dependent upon the concept of entropy. Okay, and when you come to the cart, right? So cart is nothing but classification and regression trees. So cart is actually dependent upon Gini index. Okay, you can call it as Gini index or Gini index, not a problem. So Gini index. And this cart is basically used for regression tasks. Okay, that means predicting for a continuous variable. ID3, C4.5 are mostly used for handling the classification tasks. Okay, now let us see the terminology, right? By this time, you already would have understood what is a root node, what is a decision node, and what are leaf nodes, terminal nodes, decision nodes, right? So you already would have understood by this picture, right? So let us try and understand even more, in detail. So root node is where the tree actually starts to split. Okay, so it is a condition where it starts. So you might have two conditions, you might have three conditions, you might have four conditions, you might have five conditions. So you might have multiple conditions, right, in where the tree starts to split. And then you have something called as a decision node. So decision node is something where a decision is actually taken. For example, when something splits at the root node, and then you have a certain nodes which are called as the decision nodes. So it is like a node within a node, right? Or you can say decision node again. You might have certain terminal nodes which are associated with the decision nodes, and then the leaf nodes. So leaf nodes are nothing where we can also call it as a terminal nodes. So simple terminology to remember for leaf node is nothing but the terminal node is basically the leaf node. So that means even more splitting is not possible. There it has to end. So next is the subtree. So subtree is nothing but a graph, as I already told you, because basically a tree structure is nothing but a graph. Okay, so you would have heard graph theory in mathematics, right? Discrete mathematics and all. So it is exactly the same thing what you study, a graph and tree. So that same tree concept is only a decision tree actually. Okay, so subtree is nothing but a specific portion of a particular tree is called as a subtree. Then you have a very important concept which is pruning, right? So pruning is nothing but cutting down the unnecessary branches when overfitting happens. So basically the main problem of very rarely you will see decision tree going for underfitting, right? It doesn't happen. Underfitting doesn't happen more often. So usually you are going to see the overfitting being happening when it comes to when it comes to decision tree. So to eradicate this problem of overfitting, we actually do the pruning also. So that is why this overfitting is a huge problem when it comes to decision tree. That is the reason sometimes in certain scenarios we don't use the decision tree, we use the random forest. And random forest is basically nothing but a collection of decision trees. So that is why I told you without decision tree there is no random forest, because that's why we are calling it as a forest, because forest is nothing but a collection of trees. So on that basis they have renamed it as, or they have named the algorithm as random forest. So first you have to understand what is a decision tree, and then you can understand the random forest part. So to eradicate this overfitting problem, instead of taking one decision tree, we use multiple decision trees in order to take a decision, and that decision is based on voting system. So that is how a random forest actually works. Okay, so that is how random forest is more effective compared to that of the decision tree. But basically if you talk about random forest is nothing but a collection of trees only, so it is basically decision tree again, right? But instead you are using multiple trees instead of a one tree. That's the only difference when it comes to random forest and decision tree. So next is the branch, right? So here we have different kinds of sub branches when it comes to the tree structure. So let us and next we have the concept which is parent and child node. So these are basically sub nodes only again, right? So the main subnode is basically called as a parent node, and something which divides from the subnodes are basically the parent nodes. Sorry, basically the child nodes. So this is this structure we have already seen. Let us move a little forward. Okay, so now let us understand this with an example. Okay, so let us take a very small example before going into an actual data set and trying to understand in detail. Okay. So the first important thing here is you can see a very small data set which consists of 10 observations, right? So in this 10 observations, you can see that there is day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And you can see the weather conditions which are sunny, cloudy, rainy, right? You can see three classification, right? Right. So there, I think, yeah, sunny, cloudy, and rainy. These are the three I can see in the data. And then temperature is again three are there, which is cool, mild, and hot. Okay. And then we have humidity, which is I think here we have only normal and high, right? Yeah. And then we have wind. Okay. Now, which is again we have two, only two. Yeah. Strong and weak. So we have weak and strong winds. Now, leave the day part out, right? Apart from the day part, which is irrelevant in the situation, you have conditions like weather, temperature, humidity, and wind. So these are the four parameters which are there, which are the independent variables. Now you can see the outcome is nothing but whether the person has to go out or a child. Let us say a child will go out and play or not. So if the weather conditions are sunny, the temperature is hot and humidity is very high and wind is weak, the child is not going to go for a play. Okay, right? So if it is cloudy, even though the temperature is hot, humidity is high, wind is very weak. Since it is a cloudy day, the child is going out and playing. So like this, when you have a data set and if you build a model, right? So if the weather condition on a particular day, if it is like this, what should the child do? That is how you can understand by constructing a decision tree. Okay. So let me move forward. So decision tree, a very small sentence which I've mentioned here, that I wanted to tell you. The second point where it is nothing but an if-else statements, a bunch of if-else statements in layman terms. So that is, a very easy way to understand a decision tree. So for example, when I started, that is the reason, I was telling you that. So for example, if you are having a particular decision, what are the outcomes if I take this decision? What are the outcomes if I, decision one? What are the outcomes if I take the decision two? Again, you may have even more decisions when it comes to the, splitting of a decision two or a decision one and so on. So basically, if what if this happens and then, then the else condition. So if you see logically, it is a bunch of if else statements, correct? No? So, if you're into computer science, you would have understood what I told you. So it's basically a bunch of if else statements where, you're trying to take if else, if else, if else, and then you're trying to, take a decision based upon the if else, any if condition, and based on that, any else condition can be taken also. Just give me a minute. Okay, so let us continue. So the diagram, I think you would have already understood that what is going to happen. So for example, if it is sunny, cloudy, or rainy, so then what we are going to do? So whether the next feature, which feature is very important, right? So here it's a very small example, right? So we'll go into a larger data set and, we'll try to analyze the decision tree and we are going to, do things. Now, if you want to check something, right? So if you want to check something based on a certain parameter, the main thing here is, for example, let it be a classification problem. The main aspect here, what we are actually going to do is, we are going to build an entropy in such a way to predict that, what is, first of all, why entropy is also used is to predict which feature is very important in all the features. So that also we are going to predict as well. So it plays a very important role, or it plays a sorry, it plays a very crucial role when we are trying to, build something, right? So we are trying to build a tree where we have to identify what are the important parameters in that particular tree, right? So that is in where the tree structure or the data where we try to divide it and, which parameter is actually contributing more to the outcome. So we are going to identify that. That is what the entropy actually identifies. That is why, that the concept of entropy lies in the classification problem. And the same way, Gini index lies in the regression problem. So here you can see this, decision tree for the data. Okay. So here you can see if it is sunny and humidity is very high, right? The kid is not going out and playing. And if it is sunny also, the humidity is high, right? But sorry, if the humidity is there, but it is normal. So yes, the kid is going out and playing. And if the condition is cloudy, yes, the kid is going out and playing. So irrespective of the humidity. And if it is rainy and if wind is there, the kid is not going to go out because rain and a lot of wind is very dangerous for the health. If it is rainy also, if the wind is very weak, the kid is going out and playing. So see the data set and see the decision tree. So it has simplified what decision you want to make. For example, as a person, I have a model using lakhs and lakhs of data. I built a model like this. Let us assume. Now, if the condition is rainy, right? And if it is windy, so I'll see, okay, fine. So it is strong, then it's better not to go outside. So I'll take a decision. That is why a tree structure is developed, and on that tree structure, a decision will be taken, right? Or it helps to take a decision. I think that sentence will be a right sentence to tell you that, okay, yes. So if the condition is like this, okay, fine. Let me okay, take this decision because that's what my data actually tells me. Okay, so this is how things work. Okay, so this is what just a brief where I have put where the most important part actually when it comes to this table sorry this decision tree is the very important part we should understand basically is, so when you actually which particular which particular splitting it has to do, or which is the important criteria, right? For example, there are hundreds and hundreds of variables. Okay, let us say, okay, forget about hundreds, maybe some 30 variables or 40 variables. So here you have the splitting is easy because there is only three parameters: sunny, cloudy, and rain. So what if there are many parameters, right? It is very difficult to take a decision which parameter to use to split, right? So that is in where the decision tree comes in handy. It will tell you by the concept of entropy that which parameter plays a very important role. Okay. Yeah. So this is what I just explained also. So yeah, the metric is basically the entropy concept, which is basically used for classification task. Okay, right. So now here, trying to understand is where the key important thing in the decision tree. For example, the algorithm starts, right? And we call it as a root node. And this root node basically represents the entire data set, right? And then we have, the best questions to ask is, it looks for the most important feature or question that splits the data into the most distinct groups, right? So this is like asking a question at a fork in the tree. So this is like somewhere, you're starting, or the entropy is telling you that, okay, fine. So these are the most important features. Please start, splitting by this, feature. So that is where it is very important, basically, when you start, building a decision tree. So let go forward. So next thing is the branching out. So based on the question what we have asked before, so it actually divides it into the smaller subsets, which creates new branches. Okay. So based upon the decision or based upon the important attributes or features what we are trying to take, it tries to create a new branches. That is in where it tries to split from there. So each branch represents a possible route through the tree. So this process continues until the splitting is actually done. Okay. Now let us go to the assumptions. Okay, where we are going to use when we want to actually. Yeah. So let us take some of the assumptions where, based upon how, it's like a guide or a guidance where it tells you that, what are the steps to be followed in building a decision tree. So till here, I hope there is no questions. Let me check the chat. So you can have, if you have any questions, please ask. Let me check the chat box. That's yes. So if you have any questions, you can ask. I'm just waiting for any questions. I couldn't see any. If you don't have any, I can continue. I think we don't have any. Yeah, can go ahead. How is it different from the linear and classification mode? So decision tree is actually based upon the entropies and all. They use the logarithm methods that I'll explain. They basically use the logarithm concept, the probability and the logarithm. So it's actually a combination of both, logarithm, and I can say in a very simple term is it's basically a together concept of logarithm and probability. So it is as simple as that. The entropy calculation is very easy actually. But the thing is, when you have huge amount of data, because since it's a classification problem, for that we are using the entropy part. What it does is it calculates the yes cases and the no cases, and then it uses the entropy formula and all, and then it calculates. It's basically logarithm and probability only. It's a very simple calculation what a decision tree actually does. So the tricky part here is in this calculation is when you're having huge amount of data, you cannot simply sit and calculate that much amount of probability, and yes, that is why this algorithm helps us to speed up the process and calculate and give particular answers to identify which particular case is having more entropy. So based on that, this splitting happens and all. So that I'll explain on that part. So this is basically, it doesn't use that linear part and all. Okay, so it's, I can say it's basically a non-linear kind of structure. Something, it's completely different from, your linear regression or something like that. Uh, is it take more timing to train the model? Not necessarily, but yeah, decision trees, it takes, yeah. It takes a little more time to train. Yeah, that is for sure. Uh, that I'll accept. Yes, it will take. Yes, it will take because it needs to calculate a huge amount of data, and it has to calculate that entropy for all features, and it has to decide which feature is having more entropy. So yeah, my answer is yes for that. Yeah, yes, it will take. Yes. So that is why in this, that is why for a simple classification task, we basically use naive Bayes algorithm, because naive Bayes doesn't take much of time to train. So precision trees, yeah, takes a lot of time. So any other questions from anybody? Fine, I think I go ahead. Yeah, I continue. Mm. Okay. So let us continue in understanding. Right, I think no other questions. I think we can go ahead. Okay, fine. Okay. So since there are certain assumptions in where the decision tree is actually used, okay. So some of the common assumptions are the binary splits, right? So basically, this decision tree makes some binary splits, meaning that each node actually divides into two subsets based upon the features. So this is a choice where a particular node actually makes. Okay, so at least two splits it will try to make. Okay, now, the next thing is the recursive partitioning, right? So this is basically a technique or a process, I can say, where it is a way of dividing into child nodes. So basically, I think you already understood that what is a parent node and a child node, right? So child nodes are nothing but a decision and a terminal nodes, right, for a particular decision node. That is what basically a parent node is basically. Now, if you see that what is happening inside this, recursive partitioning is this parent node or this node, what, basically it's splitting into parent node from parent node to the child nodes. And this process continues until the criterion is met. So this is what is called as a recursive partitioning. See why? Because it has to divide, it has to simplify more into, final, it has to divide more actually, and till it has to where there is completely you're coming to a terminal node, right? So there is no more decision nodes to go further, right? So you have reached the end, right? So you have reached the end where you cannot, divide even more further. So till there you have to divide, right? That is what the concept of recursive partitioning is basically is. So next is the feature independence. So feature independence is nothing but having the each feature, right? Each feature in the data set, right, or in the data should be independent, right? That is why the word feature independence. That means they should not depend upon each other. That means basically depending is nothing but the correlation, right? We already know that, right? So the features or the independent variables should not be correlated much, right? So they should have very less correlation among themselves to start, you know, uh, because if they are independent only, the decision can be taken very easily. Okay. So next is the homogeneity. So here, decision trees actually aim to create a homogeneous subgroups. So because what happens is it tries to divide the samples, and then based on that, it tries to train and achieve the target variable. So for this, it has to build a clear boundaries. So that is the reason it has to, what it does is it creates a group where it can, or you can say subgroups or groups, yeah, you can tell anything, which will try to train by using that particular subgroups. Next is top-down greedy approach. So this is nothing but the splitting of the tree starts from the top. It doesn't happen from the bottom, so it is a top-down approach. So next is the categorical and the numerical features. So here it can handle both data as we already have spoken about. So it basically handles both, which is numerical and categorical. So next is the very important assumption is the overfitting part. Because as I already told you, the decision trees are basically prone to overfitting. So that is the biggest problem in decision trees. To address this only, we are using the concept of random forest that I already told you. So this problem is taken care of in random forest. Okay. So next is impurity measures. Basically, the decision trees use impurity measures like the Gini impurity or entropy to evaluate how well a particular class can be separated. So, based on these, methods like the Gini impurity, which is used for regression, and entropy, which is used for classification. So, based on these concepts, how the tree actually can be split, that can be measured by using these impurity measures. So next is no missing values. So basically decision trees assumes that there are no missing values in the data set, or there are missing values which actually have not been properly handled through imputation, or the other methods. So next is no equal importance, no sorry equal importance to the features. So basically each and every feature is given equal importance, and before going into applying the concept of entropy or Gini Gini index, basically they are given equal importance. Okay, and once they are given that equal importance only, then we can start calculating on which the emphasis on dividing the features can be taken care of. Next is no outliers. So like the no missing values, the expectation of decision tree is that there are no outliers in the data set. So next is the sensitivity to the sample size. So basically what happens is we need a larger sample when we come to the decision tree part, right? So here, yeah, there is a problem where you can see, what I mentioned, where you can see small data sets may lead to overfitting and large data sets may lead to complex trees. So either way, it is a problem when it comes to decision trees, right? So it should be I can say, a decent a decent amount of size where you can a decent amount of size where you can actually build the you can use for training and testing the data set. So you need a decent amount of size. So here when we go to the next thing, which is entropy. Okay, so I've put one small example also, we'll get to that. So entropy is nothing but uncertainty in the data. Okay, very simple. This very, I mentioned this simple line because, people think a lot of, what exactly is entropy in a very small information, because we have a formula, we calculate, all that is fine. But what does this entropy tell you? So it tells you among the uncertainty what is there in the data set. Very simple terms, you can remember it like that. Now, let us see how this uncertainty comes into the data set. Very small example, which I found very interesting. So I just mentioned this. So suppose basically you have a group of friends, okay, and you decided that you want to watch a movie together, okay, on a Sunday, okay, and there are two movies. One is Lucy and Titanic, okay. Now everyone has their choice, right? Right now, after everyone gives their answer, we see that Lucy gets 4 votes and Titanic gets 5 votes. Okay. Now, we should decide which movie we want to watch or which movie we want to see. So, isn't it hard to choose one movie now, right? Because the votes of both the movies are somewhat equal, right? So they are equal. So you may say that 5 votes, you can see no sir. But if you logically think they are very similar, so something where you're not getting, for example, you're not getting like 5 votes and 1 vote. So they are kind of similar. Now this is exactly we call it as disorderness. So there is an equal number of votes for both the movies, and we can't really decide which one to watch. So, for example, as I mentioned, if there is a votes for Lucy, which is 8, and Titanic, it was 2. So it was easy to vote for Lucy. But since it is a very close one, right? So 4 and 5. So, you may argue with me, but that doesn't happen real time in the real time data. So here we try to output which movie to watch. So now we are applying an entropy. Okay. we can apply the entropy formula. So this is the entropy formula. This is basically divided, or you can say basically what does is this calculates the probability of the possible class, positive class as well as the probability of the negative class. Now it's a very simple formula. S is nothing but the sample size, or you can say the subset of the training sample, which is basically the sample size. And here you can see a very simple formula, which is minus p into log p. That's it. Okay. So we can take, because both are log p's, we can take it as p1 log p1 and minus p2 log p2. Okay. Or we can take, if here it's a binary case, so you can take minus logarithm of positive cases and logarithm of negative cases. So it's a very simple formula to calculate. Here the probability of the positive class, which will be here in this case, total 9 outcomes are there, right? So if you take whatever, if you take Lucy, if you take Titanic as positive, right, and the it gets 5 votes, right? So it becomes 5 by 9 minus 5 by 9 into log 5 by 9 minus 4 by 9 into log 4 by 9. That is how you calculate the entropy. So how do decision tree uses entropy? This is what we have to next. Okay, right? And first of all, we understood what is a entropy, and now how this entropy gets implemented into the decision tree. That is what we are going to understand. So, and till now we have already understood that what is an entropy. Entropy is nothing but the impurity in the node, or you can say uncertainty in the data. So I can say, one more word, which is the degree of randomness. Okay, it tells you how random our data is. So there are many ways to remember entropy. So you can say impurity in the data, amount of randomness in the data, the uncertainty in the data, right? All those things which are same, which leads to the concept of entropy. Now, if our split is more pure, right? So we should be either getting more of yes or a more of a no. So that means if we are in the balance, it is very difficult to choose which decision has to be made. So, that is where the entropy comes into the picture. Now, suppose again, considering one more, the same scenario, if the yes is a 8 and no is a 4 case, initially after the split, the left node gets 5 and 2 for a no. So whereas the right node gets 3 and a no. So this is in where the split is not pure. Why? Because we can still see some negative in the both the nodes. So here what is happening is, since we have negative cases in both the scenarios, right? And since we are getting negative cases in both the scenarios, it is still difficult for us to that is why we need to calculate the impurity in the data. And if the purity is 100% or if the purity is more high, it is easy to split the node. But if there is a lot of uncertainty, that you cannot blindly go and take a decision when there is a lot of yes no scenario. For example, if you see somewhere 50 to 53% yes, and you cannot say it is a yes, right? And you cannot go with 47% no also, because it is it is lesser also, and they both are close by. Okay, so to overcome this bigger problem, we are using entropy, but the problem even gets bigger when you have more when you have more you can say features, and which feature has to be taken, and whether the outcome is basically based on that training data, whether the outcome will be a yes or a no scenario, whether that particular outcome has to be classified as a yes or a no. That is in where in random forest what we do is, after doing here itself, here it is like a voting scenario, right? And apart from this, after the model is again built, again based on the outcomes, we are again building some more decision trees, and in that decision trees we are again going for a voting. Most voted one will become the outcome in the random forest. So that is how these decision trees and random forests are basically connected with each other. So now here you can see a very small example which I have shown you. Here let us split the data and check. So here you can see yes case 8 and a no case no. Sorry, 4 with a no case. Here you can see that the feature 2 and feature 3, the data is being splitted into two parts. It's a binary split. And here you can see for feature 2, in that you have in that 8, right? In that 8 case, right? Actually, it is 7 5, I guess. There's some printing mistake, maybe. Yeah, sorry, I didn't check. So here you can see it is a 7 5, and here you can see that the 5 is a yes and 2 is a no, right? And in that yes and a no scenario. Now, if you want to calculate this for a 5 2 feature, right, the formula will become like this. I told you, minus p1 into logarithm of p1 minus p2 into logarithm of p2. That is a formula. So if you start with a yes case, right, so it becomes minus 5 by 7 into log 5 by 7 minus 2 by 7, which is a no case, into logarithm of 2 by 7. Okay, so if we calculate 5 by 7, which comes to 0.71, and 5 by logarithm of 5 by 7, which is log of 0.71. So if you put logarithm of 0.71, you'll get 0.49. Okay, so it is 71 into minus 0.49, which will become minus 0.34, and minus into minus will become plus, so it becomes 0.34. Coming to the right hand side, 2 by 7 will be 0.28, and then 2 by 7 is again 0.28, so logarithm of 0.28 is minus 1.83. So 0.28 into minus 1.83 will become minus 0.51, and again minus into minus will become plus, and the value will become 0.85. So this is what actually the computer calculates. Okay, so this is how the entropy is getting calculated. All these calculations we are not doing. Okay, so you need not worry. For every feature, right, it will calculate this. And that's what I told you. It's just about probability and logarithm. That's it only. So, if you think of decision tree and entropy, such big concepts, always remember, right? The entropy concept in decision tree is nothing but a method of logarithms and probability. That's it. Okay, it's a combination of probability and logarithms. Okay, so let us go to this third feature. Here you can see the third feature, 3 yes and 2 no scenario, the same. So total outcomes are 5. So it becomes 3 by 5 for yes case and 2 by 5 for no case. So again, minus 3 by 5 into log of 3 by 5. Again, same 2 by 5 into log of 2 by 5. So same calculation you do, you get 0.966. That is the probability of, more chance of splitting this. Okay, there's more chance of taking this decision. Okay, because the entropy is very high. So clearly we can see that, I think, yeah, 0.85 has the, lower entropy. Yeah, lower entropy should be lower. Okay, sorry. So if you have lower entropy, that means there is less uncertainty in the data, because we have told, no, entropy is entropy is basically the uncertainty in the data. So lesser the entropy, it is good for splitting. Right. So here you can see that the lower entropy actually gives you that there is more purity in the data. So greater, then you can use the yes condition to actually split the things. Okay. So now, right. So now, as we have already spoken about, basically the goal is to decrease the uncertainty in the data, right? Or impurity in the data. We need pure, more pure thing so that we can split very easily. So here, by using the entropy, we are getting the impurity of a particular node. Okay. So we don't know if the parent entropy or the entropy of a particular node has decreased or not. So that is why we are going to bring a certain concept into the entropy, which is called as the information gain. Okay. So I've not spoken about this word till now because, once that particular, impurity is very high and you're not able to split by using the entropy, next we are going for the very important concept, which is the information gain. So information gain is basically used for classification tasks in entropy. Okay, so we use only Gini index for the regression tasks. So here what happens is we have a certain metric called as an information gain. So basically this metric tells about the parent entropy has decreased after splitting into new features or not. So in information gain, for actually more probability is suitable for, that means for entropy you see the lesser probability, for information gain you see the more probability, because that means that feature is containing more probabilistic chance of the information which is actually provided, which it is used for splitting the node. So let us see what is the smaller understanding of what is an information gain. So information gain basically reduces the uncertainty, okay, or in the data set. So for example, if you see the information gain, the formula is expectation of y divided, sorry, minus expectation of y given x. So this is basically, it's not y divided by x, it is y given x. Okay. So it is y given x is nothing but the conditional probability, or I can say the dependency of y on x. So if you say y given x, that means the probability of occurrence of y, right, when the event of x has already occurred. That is what your y given x is basically the meaning is. So now it is just entropy of the full data set or entropy of only some features that we have to understand. Let us see by an example. Okay. So suppose our entire population has a total 30 instances. The data set is to predict whether the person will go to the gym or not. So let us say 16 people go to the gym, okay, and 14 people don't. Again, see the yes no scenario is a very close one, right? It's not like in 30, it's not like 25 people go and 5 people don't. It's not like that, right? They are very close by. So 16 people, 16 people go, right, and 14 people don't. So it's a very close by scenario, right? And now we have some two important features, whether they are going to go for a gym or not. Here the feature one tells you that it's a energy column, right, or a feature which gives you two values, which is high or low. So if they have more energy, they might go for a gym. If they don't have high energy, they might not go for a gym. So yeah, it may, you can think like that. Or there is one more feature which is called as the motivation. So whether that person has motivation to go or he's neutral, or that person is highly motivated to go for a gym. So, these are the two features which we can think of. Now, let us think that our decision tree has these two features. Now, we'll use this information, which feature should be used to, split the root node, which has to be replaced after that or placed after the split. So for that, we can use the information gain. So here you can see if the energy levels are high, right? So circle indicates that the person will go for a gym, right? So if the energy levels are high, okay, for example, 16 people go to the gym. In that, if the energy level is high, 12 people go to the gym. Okay. And again, one doesn't go. And if the energy level is low, 4 people go to the gym and 13 people don't go for a gym. Okay. Now let us calculate what we are going to actually do. Okay. So now you can see that in the total 16 people who are going for a gym, you can see the splitting of 12 and 4. So circle, you can see 12 people go to the gym, in that who have energy high, and 4 people go to the gym who has low energy. So that becomes 12 plus 4, 16. And this here 1 plus 13, which is 14, which is the person who is having high energy, right, will not go for a gym, and person with low energy is going for a gym. Okay, so this is what our data basically is. Now this is how you calculate the entropy first, right? Then from that we are going to calculate the information gain. So how entropy is calculated we have already seen, right? So minus P1 into log of P1. So there are yes conditions, which is 16, which is going for a gym, and no conditions, which are 14. So if you calculate that, you are going to get a approximately 0.99 probability. So if you are having, as I already told you, if you are having more probability, right? So if you are having more probability, that means more entropy the lesser chance of taking a decision because high uncertainty is there in the data. So never you should have high entropy. If you're having, then definitely you have to go with the information gain to make a split. Now, what we are trying to calculate is two conditions where if the person, if the, if they're having more energy as high, right, and they're going for a gym. So now, again, you can calculate the entropy for that, which you are getting 0.39. And if the energy level is low, right, they are going for the gym, right? So what are the conditions? So you're getting an entropy of 0.79. So here to use the information gain, you cannot use the 2. So what we have to do is we have to go with the weighted average. So we are going to use the weighted averages method, right? So and then we are going to calculate. Then we will go with the information gain, and here you can see that the information gain is basically about 0.37. So here the information gain has to be low. So now when I actually told you about the entropy of the parent split, where you can see 0.99, it is very high, right? You cannot make the decision. So for example, we try to reduce the, we try to use the method of information gain, right? How? Because what is happening here is the most important thing is in the energy high and low, if you calculate or if you see, there is a lot of difference between the high and low. In low, sorry, high, you are getting 0.39 and low, we are getting 0.79. So that actually tells you that basically you have to split your data node or the root node by using the energy level high. That is what the, uh, you know, that is how the splitting actually will be done. Okay, with the energy high. Now the next condition is we are going to use one more feature, which is motivation. So this is also there again. So in this, star indicates the going for a gym, and sorry, circle indicates going for a gym, and star indicates not going for a gym. Correct now? In that this time it's not two categories, but it is three categories. So in three categories, one is highly motivated people who are going for a gym, and for going for a gym or not going for a gym, and there are some neutral people who are going and not going, and no motivation people. So in the 7 plus 4 11, 11 plus 5 16, yeah. So in that 16 who are going for gym, 7 are having no motivation, 4 are neutral, and 5 are highly motivated. So, those who are not going for a gym, 1 plus 6 is 7, 7 plus 7 is 14. Yeah. So, in that, those who are not going for a gym, highly motivated are 7, neutral is 6, and no motivation is 1. So, this is how the same thing you calculate the entropy. So, again, if you calculate the entropy, you're getting an entropy of 0.99. So, if you see here, with neutral and high motivation is basically 0.97 and 98, and with no motivation is 0.54. So you can use the no motivation to split actually. Okay. Yeah. So here you can see the information gain is about 0.13. Okay. And since the probabilities are basically 0.54, 0.97, and 0.98, we calculate the weighted average, and the weighted average is around 0.86, which is very, you're going, when you subtract it, 0.99 minus 0.86, you are getting a information gain of 0.13. Now we see that the energy gives more reduction, which is 0.37, other than motivation. So hence we will select the feature that has the highest information gain and split the node on that feature. So in this example, what is happening is we are taking the energy as high, right? And you can see, yeah, I've mentioned clearly in this example, energy will be the root node mode, obviously, because energy should be high. And we'll do the same here for the subnodes. For example, here, what is happening is when you calculate, yeah, the information gain for the, what is this? Energy, yeah. So for the first feature, energy, when you calculate, you are getting an information gain of 0.37. As I already told you, information gain should be more. For example, if you have 10 features, to start your root node, which feature you want, you calculate which feature is actually giving you more information gain, right? And here we have only two features. One is energy and one is motivation, right? So in these two, For the second one, the information gain is only 0.13, right? And for this, the information gain is 0.37, right? So it's a pure mathematical calculation which happens inside a decision tree. So which probability is higher, 0.37 or 0.13? The probability in the energy is higher. So obviously we are going with the split of energy than the motivation part. Okay. So that is what I've mentioned here. So instead of motivation, right, we are going with the energy part. First, we are going to give preference to the energy part. From there, we will take it down with the additional decisions what can be actually taken. Okay. So the most important thing in decision tree is basically when to stop splitting. This is a very important criteria because when we have a huge amount of data, it is very difficult to understand and it is difficult to stop somewhere at a particular feature. When to actually stop splitting, because what happens is if you keep on calculating and if you keep on building it, we don't know at a certain place when to stop and when to take a decision. For that, what we are going to do is you because sometimes we have a huge tree, as I already told you. So that is what I mentioned here. So usually real world data sets have lots of features. Here we have only just seen as an example of 2 features, 3 features. So that doesn't happen when it comes to the real time. So we have many, we can say many features which will be there. So which will result in a large number of splits, which in turn gives a huge tree. Correct? No. So such trees take a lot of time to build, right? So one of our faculty, I guess, they were asking about this. So so is it because of this calculation part, and it's going to calculate this probability in logarithm, it's going to take more time to train. Yes, it takes a lot of time because there is a lot of tree which has to be built, and usually these trees take a lot of time to build and can lead to overfitting problem because there is a huge tree which is involved. And when there is a huge tree which is actually involved, which actually basically leads to the problem of overfitting. So that means the tree will give a very good accuracy on the training data set, but yeah, that is what overfitting is basically is. So overfitting is basically the training data performs well and the testing data doesn't perform well. So there are many ways to tackle this problem, right? And here, one of the things is, using the max, there is a function called as, grid search CV. Okay. So this will actually use the function max depth. Okay. So I can understand in a simple way. Okay. Let us not complicate much. So, we can use the parameter which is maximum depth, right? And you can use the library which is grid CV, grid search CV, to identify the maximum depth, and based upon that we can stop the tree before going into complex splitting. Okay. So yeah, another is the using of the minimum sample size. So that this is also another way, right? So the first one is also very used actually. Grid search CV is basically used along, a lot to actually do this. So another way is also is using the minimum sample split as well, and then we can we use the small samples to split the data. So that means this means we have lesser samples to usually split the data point. So I think I got a question. Let me take this. So that's what I was telling Prakash. Uh, Random forest can be used for image classification. Yes, you can use Neha. Yeah, you can use it. So how to overcome fitting? That is what I'm discussing, sir. Prakash, I guess, sir or student. I'm not sure, but you can use this pruning concept. Basically, when we use pruning, huh? So pruning is basically cut downing the aspects of over branches which are built extra. right? So that's what the biggest problem of decision tree. That is what I was just speaking about as well. So if there are a lot of features, the tree grows and grows and grows. That is a very tough challenge to take up as well. So it is always important to identify at a certain level and cut down the tree and stop the training process in order to, sorry, in order to that the tree doesn't grow too much, and yes, it doesn't grow too much, and the problem of overfitting doesn't occur. And for that, I was explaining a couple of concepts. One is the concept of minimum samples, and one is the feature of, sorry, one is the concept of maximum features. So what happens is, using this maximum feature function, this maximum feature basically it decides the number of features to consider when looking for a best split. So this is where we use the grid search CV to do this particular task. And next is the minimum sample. So this is basically dividing the data into minimum samples and trying to train based upon that the tree doesn't go for overfitting. Okay, this is one more thing what can be actually done. So next is the pruning concept. So before that, let me check any other questions are there. Just give me a minute. I don't think we have any more questions. Please. If you have, you can ask, please. Gradient descent. We use gradient descent particularly when it comes to the ensemble techniques, sir. So yes and no for your question. Why? Because in particularly decision tree, we are not using this gradient descent much. But I would say we use this gradient descent when it comes to ensemble techniques. So ensemble, we have many techniques like gradient boosting, ADA boosting, random forest. We will cover some of the ensemble techniques also because it is very important. So I just started with the decision tree, and then we can move on with random forest and then go with the bagging and boosting techniques. So yeah, we can use it in the random forest part, or I can say ensemble techniques, but not particularly in decision tree. I have not used much in my experience. Not used much of gradient descent in decision trees. So yeah, yeah. So to be fair, to teach the students or to do a very small projects, I have used decision tree, but to on a bigger picture, I would say we have gone with the random forest only because, as I already told you, it's a collection of trees, and you can make a decision uh, on because as and you may get a doubt. So directly we can go to random forest, but you should understand decision tree first, right? And then you can go to the random forest part because see you'll be understanding random forest very easily if you already know decision tree. So that is the reason I didn't want to skip the decision tree part. We have to understand, according, a step-by-step learning procedure. If you want to learn like that, always it is good to learn the decision tree and then go to the random forest. So that's how even I feel that's the way it should be taught. I do that the same thing only. So anything else? Any other questions? I'll just take a couple of more minutes. If you have any questions, you can ask me. Um, So the projects, what we can do is in decision tree is, one of the very important projects. I even shared the data set also. So predicting a fraud is, one of the very important um, projects. For a smaller projects, you can use the, uh, decision tree as well. But if you talk about the bigger projects, particularly I worked on, projects where, we have done the fraud detection. So that's why even, this particular finance data, the fraud detection identification, even I've chosen to, do that for you guys as well. So because, fraud detection is one of the very important, part of, very important part of, in the current day scenario. That is what I feel. So, you can implement fraud detection as a very important, as a, a project if you want to do as well. When it comes to the decision tree part, decision tree and random forest combinedly. So even I'll be implementing with the fraud detection data set only for both random forest and decision trees. So I'll take that, which you can actually implement. We have many projects you can do wherever classification can be used. You can use decision trees. It's not like, no restrictions. You have to use here only. So even, if I say even email spam filtering also, so you can use the decision tree, right? And when you have multiple decisions to make wherever in whatever scenario, based on certain parameters, whether a particular product has to be launched in a particular market or not. So this is again a classification problem. So again, for this also you can use the decision trees. So right from the product, inventory, and right from any scenario, you can use the decision trees in the real time. But I feel, as I told you that, I feel, fraud detection is one such area where decision trees are good, but still, but that is also good with combining with random forest, not in a, not in a individual, not in an individual way, but combined with the random forest part. So anything else? So guys, you can just ask me or we'll move forward. I think it's good to go, I guess. Okay, fine. I think we'll continue. Okay, so let us see what is pruning. We have actually discussed this already, but let us understand. Basically, pruning is used for, to avoid overfitting problem. Okay, and this, to, if we avoid the, tree to build, more subnodes or nodes, right? Uh, and it is not good for us when we are having any, particularly any significant, insignificant data nodes, subnodes. Why? Because why to build a tree which actually, which is not, a particular subnode, which is not important. So what happens is that we have already have talked about where it takes a lot of time to train and to apply the formulas and all those things and do. So that is a tough thing which or it takes a lot of time to actually do this. So that is the reason we actually try to cut down the unnecessary uh, we try to cut down the unnecessary branches, right? So that the data actually, the training part doesn't take much of time. Okay, so that is what in that the first thing, we have two things in pruning. One is the pre-pruning and the post-pruning. So basically, the pre-pruning is about we can stop the tree growing earlier, right? Which means we can cut down, remove, right? Which is not important or low important features. But when it comes to the post-pruning, once the tree is developed, we can then also cut down the very important, not so important things, right? Because we have not stopped at the initial stage. At least we have to remove the insignificant things so that we can actually move forward and build a decision, right? So this example we have already seen. Okay, so we'll see one small conversation. Okay, so is the weather sunny, right? So branch is saying is a person indeed. So next node is how windy it is. It is asking, the branch node is asking, okay, indeed. And the next node is asking how windy is it? Then branch is saying remain indoors. It's too windy for comfortable play. Okay, it's a very funny conversation, right? So then the branch is saying no. S branch is saying one thing and no branch is saying go play. Pleasant sunny weather is ideal for the outdoor recreation. And then the next branch is telling if it what if it is raining. So yes branch is telling remain indoors since it is raining. It is uncomfortable to play outside. And again the no branch is telling no, it's gloomy. It is good only. It's not raining much. You can go outside and play. So like this you can have multiple decisions, right? In that way, a decision tree is actually useful. So now let us understand that, to conclude this, so beyond predicting the weather, decision trees are utilized for various things. As I already told you, identifying the spam emails, classifying and forecasting the loan approvals. So that is why I told you in finance sector, I have seen more implementation of decision trees and random forest because they are very, very good classifiers when it comes to a finance field. For example, a loan approval or whether it is a fraudulent or a non-fraudulent transaction. To identify the risk assessment, decision trees and random forest are one of the best algorithms for that particular task. Okay, so let me stop this and let me share my data set. Okay, so let me see some. Yes, sir, you can use, yes, faculty or student, I'm not sure. But you can actually use. So because I can see, can we use decision trees and fake news detection? Yes, you can use. Yeah, you can use because there is a classification thing. To answer your question on a briefer note, wherever you have something as a classification or regression as well, you can use decision tree. There is no other, no other answer for that. You can use it, but the problem comes is, but the only thing to your question is how effective is your decision tree in that particular scenario. That is why even we don't just blindly go with the we don't blindly go with building one machine learning algorithm and say okay, this much only is possible. We never do that. Actually we build multiple models to predict. That's why we have multiple machine learning algorithms. It's not just one application or one thing and we are not going to decide on having one. So for fake news detection app, you can use the decision trees. May or may not, it might be good in that scenario. But in my observation, I was telling you, it was more effective. Decision trees and random forest is more effective for things, particularly in finance domain, for identifying the frauds, right? So for all these particular things, for loan prediction, these decision trees and random forests suit more. It's not like for other things you cannot use, you can use it. But for these things, my experience with projects and what I've seen, I feel for that it suits more. Okay. So I think that should answer your question. Just give me a minute. Okay. So yeah. So let me share the data set. We'll start with the discussion of the data set. So let me share. So I hope you have downloaded the data. Okay, so let me share. Yeah, it's a huge data actually, because particularly when you are applying for fraud detection, you need a huge amount of data which you can actually train on. Okay, so let me share. So this is the data set what I've shared with you. Okay, so you can just download this if you have. It's a little bigger data set, but that is the reason I have asked. So this has almost okay, it's not going down. I can pull it down. Okay. This has around units, tens, hundreds, thousand, ten minutes. Yeah, I think it's really huge. Units, tens, hundreds, thousand, something like that. Yeah, 10 lakh, I guess. Yeah. So around 10 and a half lakh size of a data set here. Okay, so it's a huge data. So I think you can see the data set. Yeah. Okay, so let me try and make you to understand that what are the things in this data set. Okay, and maybe from there we can take it forward with the application part. Okay, so now if you see what is there in the data set, okay, the most important thing in this data set is whether based on certain scenarios, whether you know whether my the payment, right? So see, understand this. Okay, so you're trying to identify the fraud detection by using a model where the model actually predicts whether based on a particular transaction whether the transaction is fraud or not. Okay, so that is what our scenario is basically. Okay, now if you see carefully, the first part, which is the step, okay, so actually the step includes the amount of time taken, or I can say the initial step of making out to make a particular transfer. So for example, if you are using a debit card, or whether you're paying through a cash out, or whether you are paying through a UPI transaction, right? So it might be any kind of transaction you're going to do, right? So whether that what is the payment type, before that is what is the initial step what will be done to do this payment part. Okay, so this is okay. So this is what the data set is actually all about. And next thing is the type of transfer, which is the whether it is which kind of payment, right? So which kind of payment is basically the which kind of payment that the particular person is actually using. right? So is it a online payment, or is it a cash out, or is it through a debit card, right? So that we are going to that we have in the data set. So next is the amount. So this is the amount which the person actually has transferred. Okay. So here you can see that the person here you can see is transferring 181 rupees, right? Here you can see the person is transferring 7,107 rupees. So what is the amount that particular person is actually transferring? So that is what the amount section basically is about. So next thing is the name. Okay. So name original. So this is a coded name because people usually when you take this kind of data, usually you will not get you know the name of a particular person due to privacy concerns. Okay, so that is why you don't have a name. Now the next thing is the old balance. So old balance indicates that before the transaction how much of amount is there, right? How much of amount is there in that uh, account. Okay, so old balance indicates how much of amount is there in that particular account before the transfer is done. So new balance is nothing but the what is the new balance after the transaction. So once the transaction is done, what is the balance in that particular account? Okay, so that is what this new balance is about. So next is the name list is nothing but the recipient of the transaction. So what is the uh, person who is taking this money? For example, this is the origin person, right? And we have this dest is nothing but the destination. So again, this is also coded because due to privacy concerns, this is also a person's ID or a name where who is taking the amount. So this is the person who is sending the amount. This is a person who is taking the amount. So now next thing is the old balance in the destination. That means the person who is actually taking the amount. Okay, so those who is taking the amount, so that person in his account, what is the old balance? So here you can see for the origin or the person who is sending, you can see the amount he is trying to send, and you you can see his old balance and you can see his new balance. To the destination account, you can see the old balance, and to the you can see the new balance, right? And of that particular person who is taking that amount, who from where the amount is coming from. So from where the amount is coming from what is the destination that play that person's old balance and the new balance. So here the parameters are very small because it is just dealing about very important things are five important things. Old balance, new balance of origin, old balance, new balance of the destination, right? These are four. And then the amount which has been sent, which is five, and whether that particular transaction has been flagged as a fraud or not. That's it only. So this data set, usually finance data sets will consider, what are the important parameters. You will not have, even though you have a lot of parameters, if you want to identify a fraud or something like that, you don't need many parameters. You only need which are very important for you to calculate that particular aspect of whether that particular transaction is a fraud or not, right? So yeah, so let us dig deep into understanding the understanding the data, how we can construct a decision tree. So now let me directly share the let me stop sharing this. Okay, let me stop sharing this, and let me go to the okay. So let me go to the data set. Let me share my screen. So in the meanwhile, I can just see any. Um, me share the Python. Okay. Now let me see the Python. Let me show you the Python. Okay. So now you can see that we are starting the practical part of that using that online fraud detection. Okay. Right. So here you can see that uh, you know here you can see that these are the necessary libraries which we are actually taking. Okay. So now the pandas is basically used for data frames, and NumPy is basically used for arrays. Plotly is basically used for plots, and you have a model selection, which is basically a module in sklearn, which is basically used for training and splitting the data. Then you have decision tree classifier, which we are going to classify because we are not using a regression here. We are using only a classifier because we are trying to identify whether the transaction is a fraudulent transaction or not. So here we are using the tree module. In that tree module, you have the decision tree classifier. Okay. Now let me read the data set. I've already done this. It may take a little bit time for you because the data set is it's extremely huge. So here exactly the correct shape is actually given. It's in 100,000, 10,000 lakhs, 10 lakhs. So our data set is actually a size of 63 lakh. Okay, so it's a very huge data set. What we are actually trying to do. Okay, so for reading only, it taken for me it has taken a minute to read the data set. Okay, because for reading also so much of it's around 470 MB, so around 500 MB data set it is. So usually when you see a data set, you'll be the data sets that I have shared previously, you may see the size of the data set might be some 250 KB or 500 KB, not even 1 MB, maybe sometimes 1 MB or 2 MB. But here the data set itself is around some 500 MB, 470 I think to be precise. So it's a very, very huge data set, and usually we have, for fraud detections in the finance sector, we have these kinds of data sets. So that is the reason I wanted to, show you and explore that you can explore that, these kinds of solid data sets to understand the concept. Now, if we go to the shape of the data, right? So if you go to the shape of the data, you can see that the shape of the data, the columns are only 11, right? So there are only 11 columns, but the data set is actually around you know a huge amount, right? Now let us see whether the data set is having any null values or not. Okay, so if you see that if the data set is having any null values or not, if I apply this is null dot sum, as we have already discussed previously, you can see that there are no null values inside the data set. Okay, in any of the columns there is no null values. So next is the exploring the transaction types, right? So here you can see that there are 5 types of transactions. So this value, if you see here, the important function is the value counts. Okay, so the you can see in the type indicates the type is nothing but the just a minute, I'll share this as how I shared before, so it will be easy for you. Yeah, so and for the data set, you can put your address. Okay. And yeah, we are here in the fifth line. Okay. Yeah. So we are here where we are going to identify. We are going to identify based on this because the column name is type, right? So in the column name type, you can see that there's a function which is used So that function is nothing but the value counts. So if you use this function, which is value underscore counts, so basically what happens is it will count whatever, you know, for a particular column, if you are actually giving that, what are the unique things in that particular column, it basically gives the unique things. But this value counts is actually very good in my opinion than using that unique. Why? Because this value counts will give you not only the names of the unique, sorry, not only the names of the unique, but also the count of that particular unique. So this is good, right? So practically, if you think this this value counts will give you the count as well. So here you can see, the cash transactions are around some, 22 lakh, right? So 22 lakh 37,000, and payments are about 21 lakh 51,000, and cash in is 13 lakh 99,000. Transfer is 53,000. Sorry, 5 lakh 32,000, and then debit is around 41,000. So you can see that this one not only gives the unique names, but also it gives the count of the number of transactions. So the next part is basically just sharing it as well. Okay. So next part, what I'm trying to do is I'm trying to classify, or I can say I'm trying to build a pie chart to see the percentage. Okay. So this PX I'm using for that only. So this kind of pie chart we can, build. And this pie chart will tell you that how much of percentage is there for what kind of transaction. So here you can see that the debit is very less. When you convert it to percentage, your debit is only around 0.61 of the transaction. So this 8 is nothing but the transfer, okay, which is very less. And then the 22 is nothing but the, this cash in, right? So it shows cash in, which is 22%. And then your big players are nothing but the payments and the cash outs. So when think that, this is a bigger number, obviously this is contributing to up to 35.2% of the distribution of the transaction type. Okay, so this cash out is playing a major role when it comes to the 5 unique transactions what are happening in this data set. Okay, so let me go down. Next, we are going to build this. This is a very important step. So concentrate on this very much. I'll just share the code first in just thing, but to let us understand very slowly. Okay, this is a very important part. Now, what I'm trying to identify is, is there any correlation between, that, if the amount is fraud, right? Is there any correlation between, the parameters, whether, to be fraud, any particular column, is it contributing so much that, because of this, because of a particular reason, the amount or the transaction what is done is basically a fraud. So that we are trying to identify here. So for that, what we are trying to do is we are trying to identify the fraudulent transactions by creating a correlation matrix. And correlation matrix is basically calculated for, or correlation is basically calculated for, basically it is calculated for the numerical values or the numerical variables, or you can say numerical data in the data set. So here, what I'm trying to find is if there is, a particular if the correlation is very high. Okay, so just let me know that it is contributing more. But if you see here, there is none of the transactions are basically contributing much to the fraudulent transactions. So that is what I'm trying to find in this piece of code. Okay, so let me go down. Okay, I've kept my decision tree as simple as possible for you to understand. Okay, now let us use a very important thing is to transform the variables. So now here, what is basically the transformation part, right? What I'm trying to basically do is, let me share this. Yeah. So what I'm trying to do is in the type, right? In the type, we have 5 types of transactions, correct? No? So in that 5 different types of transactions, I am giving or mapping out, numbers to each transaction. For example, I am giving cash out as 1 and payment as 2, cash in as 3, transfer as 4, and debit as 5. So I've gone in an order of how my unique identifier has actually shown or value counts has shown. So this is what I'm going to map. I'm going to use the map function to map a certain categorical to a numerical value. And the same thing I'm doing for a fraud transaction as well. So for 0 for a no fraud and 1 for a fraud. Okay, so I'm going to map this. Okay, and now here I can see whether it is flagged fraud or not. So it's fraud, no fraud, it is showing here. See, no fraud, fraud, no fraud, or if it's a fraud, it is showing fraud. Okay, so that kind of that kind of thing which has been built. Now let us go to the next part in splitting the data. Okay, so as I told you, the most important thing is the type of the amount and the old balance from the origin and the new balance in the origin. So this we are using first, and we are trying to build a decision tree. So here you can see that your outcome variable is nothing but whether it is a fraud or not fraud. So here you are taking the, I think I've shared this data.head. Yeah, I think I should share this. Okay, so this part will actually give you whether you are going to identify using these parameters, right? Whether that particular transaction, right? So we are training the X variable on these 4 parameters, 1, 2, 3, 4 parameters. Okay, and we are training this Y variable with on this parameter. Okay, so now next we are training the machine learning model. Okay, so what we are doing is, as I told you, I'm keeping a very simple model for decision tree for you to understand. Let us not take complicated ones. That's why I've not taken any complicated model. Here you can see that you have something called as an X train and Y train that we have already understood. So X train, Y train, and X test and Y test. So these are the 4 splitting parameters which we can actually identify. And then we have the train underscore test underscore split function for both the X variable as well as the Y variable. So next is we are going with the test size as 0.10, which gives you 10% of the testing data. And that means I'm training on 90% of the data. Then we are going with the decision tree classifier because that is what we are building the model on. Now we are trying to fit the model, right, for both the training, which is X train and Y train. And then we are predicting the score. Okay, so it has built a decision tree model nicely. So we are having an accuracy of around 0.9997. So around almost 100% accuracy we are actually having. All right. Now let me pass a very important. Um, Here you can see. That one I think last time I told you how do we decide. Random state 42 is nothing but a fixed seed number where the the data is sure I'll send. So where the data is basically training when it applies in a very simple language I'll tell you. So this random state 42 indicates that when you use a random sample, right, the sample doesn't change. So if the sample should not change much, it is very important that you use the random state 42. It's a for standard syntax which you go for. And if you take that, so it's going to build in such a way that random sampling happens with a fixed amount of sample being trained on. So if you select the same kind of sample will come up. It's good to do like that, because what happens is, if you anyway you're the approach of building a model obviously does on the method of random sampling. So that is why we go with the random state 42. And here, if you see, I'm actually sending under okay, yeah. So fine. Now here you have something called as prediction here. Now I'm giving the type as 1. So what is the type of 1 which is there? It's a cache out. Okay. Now if you see, if you're doing a cache out, okay. So here you can see that if you're doing a cache out, the amount is 8,900. Old balance was 8,990 and the new balance is 0. And if you're predicting, it is showing that the transaction is a fraud. Okay. So, right. So that is what our prediction basically is. This is what the decision tree. As I already told you, we will build a little more complex in random forest. So that is the reason I just wanted to keep decision tree as simple as possible to make you to understand. Okay. So let me just download this file and let me share it with you guys. Okay, fine. Just give me a minute. I'll just share you the link. I think ma'am has pasted. Okay, right. Send it once again. Yeah, share it again. Let me. We'll share you this file as well. This IPYNB file also I've shared. You can just have a look on that. Yeah, the coding part also I've shared along with that. The link to the data set also. So if you have not downloaded or you're not able to follow up with the code, you can use this data set. So we can you can ask me any doubts if you have. We'll wind it up if you don't have anything. So just wait for a few minutes. You can ask me. So tomorrow we'll discuss the concept of random forest, but we'll use the same data set. Okay. So online fraud detection data set we are going to use. But the approach of random forest is little different. Right, but it is based upon the concept of decision tree. So if you are aware of what is decision tree now and understood what happens in a decision tree, so understanding the random forest is it's not a difficult task, right? And we'll quickly go through the random forest tomorrow and understand some theoretical concept as well as practical. And let us also try to discuss, right, we'll try to fit in the interview questions are based on decision tree and random forest. Okay, so tomorrow let us see that also, if time permits. Maybe or day after tomorrow session we can see. So because each based on the concepts what we are going through, we will also discuss about the interview questions part as well. So for decision trees and random forest, I wanted to do it together. That's why I have not considered some interview questions on decision trees today. So tomorrow's session will be more focused on random forest and implementing the random forest part, and then the interview questions based on decision tree and random forest. So this is what the agenda for tomorrow's session. So if you have not downloaded the dataset, at least for by tomorrow's session, you can download it and come. It's a huge dataset, 470 MB, something like that. So you can use this Python file, what I've shared as well. Ma'am is also sharing the attendance link. You can use that to update your attendance. And as I already told you on Monday, we are going to have sessions from next Monday. The session on next Monday, from next Monday, it will be from 7:30 to 9:30. Okay, instead of 7 to 9. This week we will have from 7 to 9 p.m. Okay, so yesterday we didn't had a session. So Monday, Wednesday, Thursday, Friday, we are going to have these 4 days. We are going to have from 7 to 9. After that, from Monday, we are going to have at 7:30 to 9:30. Okay. So due to some constraints, we are going with 7:30 to 9:30. Please adjust with the timing. Okay. So, ma'am, I think nobody has any question. You can wind it up if they're not having anything. Maybe we can wait for a minute and then we can decide and we can skip. Yeah.
Yeah, even I can't see any questions to be
Yeah.
addressed, sir.
Yes,
So
yes.
yeah, we'll wait for 1 or 2 minutes, then we'll wind up for the day. Thank you, sir. Thank you for your valuable class.
Sure, ma'am. Thank you.
So we'll meet again by tomorrow at 7.
Yeah.
Thank you. Yes, students, we'll wait for 2 minutes. If you have any questions to be asked, you can ask. And make sure that you all mark your attendance without any fail. Yes, sir, I don't see any questions. So we'll wind up for the day.
Sure, sure.
Yeah. Thank you all. Good night. Thank you for joining. Thank you, everyone.